Welcome to the Explainer. Today we're going to tackle a really cool idea, how we can actually use the past to get a glimpse into the future. Have you ever wondered how big companies seem to know what you're going to buy next? Or how economists can talk about the price of milk in the 1950s like it makes any sense compared to today? Well, it all comes down to a couple of really powerful statistical tools, and they're all about making sense of data over time, basically turning the past into a roadmap for what's ahead. So, first things first, before we can start predicting anything, we need to get a handle on the basic language of how data works when it's spread out over time. And that brings us to this idea of a time series. It sounds technical, right? But really, it's just a fancy way of saying we have a bunch of data points that are stamped with a time. Think about it: daily stock prices, monthly sales reports, even yearly rainfall. If it has a timestamp, it's a time series. It's data that tells a story. And here's why this is so important. By looking at these stories from the past, we can start to make some really educated guesses about the future. We're not talking about a crystal ball here, not at all. This is all about making smart, informed decisions. It's crucial for businesses figuring out how much stuff to make, or even for governments planning big projects. Okay, but here's the catch. Raw data is almost always messy. It's noisy. It's like trying to listen to a song with a ton of static in the background. So how do we cut through that noise to hear the actual music? Let's see how we can smooth things out to find the real story. Take a look at this. This is some production data. One year it's up, the next it's down, then it shoots way up. It's all over the place. Trying to spot a clear long-term trend in this is tough. It's bumpy, right? You're kind of lost in the weeds. You can't see the forest for the trees. So one of the easiest ways to fix this is with something called a moving average. It's a pretty simple concept, really. First, you pick a time frame, say 3 years. Then you average the numbers for those 3 years. And finally, you just move forward 1 year and do it all over again. You just keep sliding that window along. Let's see it in action. So we'll grab the numbers for the first 3 years here, 1999, 2000, and 2001. Add them up, that's 47, divide by 3, and boom, 15.6. The key is you plot that average right in the middle year, which is 2000. Then you just slide down, grab 2000, 2001, and 2002, and repeat the whole process. And check this out. This is what you get. That jagged line, that's our original messy data. But look at that dotted line. That's our moving average. See how much smoother it is? It just cuts right through the noise and shows us what was really going on all along, a clear upward trend. Okay, so the moving average is great. It gives us a good feel for the trend, but what if we need something more precise, a more mathematical way to find that single perfect line? That's where something called the least squares method comes in. The whole point of this method is to draw one single straight line that is the absolute best possible fit for all those scattered data points. It's like finding the perfect balance point. All right, I know what you're thinking when you see this slide. Lots of symbols, looks complicated, right? But seriously, don't get bogged down in the math. All this complex-looking stuff is just trying to do one thing: find two numbers, a and b, so we can plug them into that classic equation for a straight line you probably remember from school, y equals a plus bx. That's the entire goal. And what you get is this perfect straight line slicing right through the data. Now that is a powerful tool for forecasting, because now we can just extend that line out into the future and make a really solid mathematically backed prediction. Super useful. Okay, so predicting trends is one thing, but what about just comparing things over time, especially when money's involved? That's a whole different ballgame, and it can get really tricky. I mean, look at this. In 1985, rice was 4 rupees a kilo. 10 years later, it's 8.50. Wheat did pretty much the same. So did things just get twice as expensive? Well, no, not really, because wages also changed, the cost of everything else changed, the actual value of a rupee changed. Just looking at the price tag doesn't give you the full picture at all. So how do we solve this? We use something called an index number. Honestly, the best way to think about it is like a special ruler that's built just for measuring change over time. And here's the absolute key to how it works. You pick a starting point, a base year, and you just decide that year is 100. That's it. It's your starting line. From now on, every other year is going to be measured against that 100. So if another year is 110, you know things are up 10%. But wait, there's another layer to this. To make this comparison really fair, you can't just treat everything the same. Come on, some things are just more important in our budget than others, right? This quote just nails it. A change in the price of rent matters more than a change in the price of bubblegum. I mean, obviously, if your rent doubles, that's a disaster. If the price of bubblegum doubles, you probably wouldn't even notice. So to get a real sense of what's happening, we need to weight our index. We need to give more importance to the things we spend more money on. And again, you'll see these formulas like Spears index, and they can look a bit scary. But just like before, they're doing something simple. They're just combining two things: price, the P, and quantity, the Q. By bringing quantity into the mix, we're automatically giving more weight to the things we buy a lot of. It's actually pretty clever. Okay, let's look at how this works in a table. Focus on that last column, P1Q0. What we're doing here is multiplying the new price by the old quantity. Think about what that means. We're asking a really specific question. If I bought the exact same stuff I bought back in the base year, what would it cost me today?
So when you do all the math, you end up with a single number. In this case, 154. And because we're smart and we set our starting line at 100, the meaning is instantly clear. 154 means prices are up 54% from where we started. Simple as that.
All right, let's zoom out. We've talked about some abstract stuff, moving averages, least squares, index numbers. But why does any of this actually matter to you? Well, it turns out this stuff shapes our world in a huge way. Think about it. When you hear about economic forecasts on the news, that's time series analysis. When your company sets its sales goals for next year, time series analysis. How does the government decide where to put resources? You guessed it. And the big one, that consumer price index, the CPI, the thing we all use to measure inflation, it's just a really big, carefully made, weighted index number. So there you have it. Thanks for joining this explainer. You're now armed with the basic tools to understand how we look into the future and how we make sense of the past. The patterns are hiding in plain sight in all the data that's around us every single day. Now you know how to look for